In the quadrilateral blue, we know that BE is actually the same size as UL. So what else would we need to know to prove that this quadrilateral is a parallelogram? In fact, it's going to be choice B, where as long as we have LU is perpendicular to BE, we will get a parallelogram. That visually makes sense here, but even if we just knew they were parallel and were drawn very weirdly, like EB and UL, even if we were off by some amount, we would know that since they're the same size, they would end up creating these blue lines being parallel. And so B actually will win. What about some other choices? So why would A not work? That BL would be parallel to EU. Well, what if we had this funny situation where the bottom was huge, but we still had parallel? Well, that's awesome because, these are parallel lines, and we can create this like isosceles trapezoid where they have matching side lengths here. However, this is not a parallelogram because these sides are different lengths. Okay, so how about choice C? So choice C, what if BE were congruent to BL? BE and BL. Well, that's just silly. We could have BE the same length as B to L, and also the same length is L to U. And then we could still make a trapezoid instead of a parallelogram. So that's no good. Choice C is out. Now, last but not least, for D. So for D, what if LU is congruent to EU? Well, you can see we just highlighted the bottom corner, just like earlier we highlighted the top corner. So this is going to be the exact same logic, so it won't be D. Now, the second problem is very simple. We have a triangle that when we do stuff to it, it turns into some kind of other triangle. However, we wonder what ways we can affect it. So what ways can we affect it where we won't get something congruent? Now, if we just go ahead and reflect the triangle, it doesn't really matter. Let's see. If we just reflect the triangle, it's just going to flip it around and not mess up its size. So it won't be A. And what about B, a reflection? Nope, that's still going to be fine. C, a dilation with a scale factor of 1. Now, what does that mean to dilate with a factor of 1? Well, you're not becoming twice the size, or 1/2 the size, or 1/3 the size, or 3 times the size. You're staying the exact same 100% of the size. So that's not changing the size at all. And it has some center, which is okay. So C is actually fine. Choice D will be the only one that's kind of bad. Now, if we dilate with a scale factor of 3/2, that's like we're taking our triangle and we are increasing it in size by 3/2 or 1.5. So that is no longer congruent.